Hello everyone. This week's this week's video is about pricing and revenue management for perishable assets. We talked about perishable assets when I was introducing you to the idea of pricing and revenue management before. And in the last video, we looked at some very interesting ideas behind pricing and revenue management. We talked about pricing for pricing and revenue management for multiple customer segments. So we have different segments who are willing to pay different prices for the same product, maybe because time is a factor or speed is a factor or something like that. In that case, you can price them at different price points, and we talked about that in last week's videos. And we also looked at allocating capacity when you have uncertainty. So let's say that you have two different types of customers, ones who are willing to buy your product well in advance or even pay less, and others who want the product almost right away but are willing to pay more. Then how much do you set aside for each of those segments, right? So here we talked about pricing for those segments, and here we talked about how much capacity you can set aside if there is uncertainty in how much the higher paying segment will want from you. Okay, so in this week there are two models that we'll talk about. One is dynamic pricing. Dynamic pricing is something that we are all familiar with, given Uber and what everything that happens around it. We look at something similar here, and we'll also look at overbooking sales of an asset to account for cancellation. So those are the two models that we use for pricing and revenue management for perishable assets. So first, let's talk about dynamic pricing. So the model for dynamic pricing is actually very similar to the math behind the model for dynamic pricing. It's very similar to the math behind what you had for multiple segments. So if you look, the model will the mathematical model is exactly the same. In fact, because this is exactly what we were doing. If you remember from the model here, the major difference here is that here we were looking at profit as a motive, so price minus cost. You're maximizing profit, but when you're looking at when you're looking at dynamic pricing, you're just going to use you're going to maximize revenue. Cost doesn't come into play, right? So the idea is effective differential pricing generally increases the level of product availability for customers. So given that by varying pricing, you can potentially charge customers more. But the reason to charge customers more would be to make sure that customers who are really in need are getting what they need, right? So let's look at this model. Sorry, let's look at this example. A retailer has purchased 400 ski parkas before the start of the winter season at a cost of $100 each. So it's 400 times 100, so $40,000 is the total cost. And again, for this, cost doesn't come into picture, right? So something to keep in mind. For the season lasts for 3 months, and the retailer has forecasted different pricing for each of these three different months. So forecasted different demand for each of these three different months, and so potentially have different pricing for each of these three different months. So how should the retailer vary the price of parka over the 3 months to maximize revenue? So demand, there is a linear model for demand in all three cases, and then we can maximize this profit subject to the condition. So there is a condition that you have only 400 parkas available. So you have that there. So this is a capacity constraint, and yeah, so we can solve it. So the way we set it up is actually very similar to the way we set up the pricing for multiple segments. So I'm gonna create, no, not read. I'm gonna create a copy in a new book. Okay, so you'll notice that demand has a formula here and profit obviously. So now when you're writing formulas, we are not going to be no wait, this is revenue, right? So price times demand. So yeah, so in fact when I set it up last time, I guess I set it up wrong. This should not have been. Okay, I'll make a change there. Right. So there was a mistake in this Excel file, because again we went for revenue rather than profit here. It should have been revenue minus cost, I think, but I can fix that. Right. So everything is set up properly here. Again, let me clear everything. Uh, so we don't know what the price is. Right. So we don't know what. Okay. I subtracted cost directly from here 10 times. So there won't be any cost here. So yeah. So there's no mistake in the previous. Right. Yeah, I don't think there's any mistake in the previous case. No. Another thing is that we don't have price segments. We have different months. So what do they call it here? Period. Different periods. So let me so let's write out the formulas for demand first. So the formula for demand is right. So here you go. Formula for demand is 300 minus P, 300 minus 1.3 times P, and 300 minus 1.8 times P. So it's 300 minus first is 1 times P. I don't have to write 1, so 300 minus P. This is 300 minus 1.3 times P, and 300 times minus 1.8 times the price, right? So that's 1.3 and 1.8. Yes, that so that is correct. So we have the demand values here, and we have the profit values here. And I'm going to write the model right here, and yeah. So this I should probably be done in another 10 minutes with this recording. So these are the demand values, and then we have profit values. So instead of profit, we're going to calculate revenue and not profit here. I'm so sorry. So it should say revenue. So revenue should be whatever your price is times whatever your demand is going to be, and it's going to be the same throughout. And when we write the profit, it's just going to add the total revenue here. Right? So that's the total value that you have. And we have a constraint on the total demand. Total demand cannot exceed something. So these are not dollar values. Okay, so now let's look at the constraints. If you go to the solver and write the constraints, let me clear everything. So the objective is to maximize revenue. So I'm going to say maximize revenue by changing the price value. So we are dynamically pricing them. So that's the dynamic pricing. Yeah, leave it at non-linear. I'm going to add the constraints. The first one is that the total demand has to be less than or equal to 400, right? So I'm going to say capacity is here, it should be 400. I'm going to change that to 400. Uh, Total, we have 400 partners, not 4,000, right? So we have the demand constraint. What else do we have? That's pretty much it. So that's the constraint. The next is the non-negativity constraint, if I remember correctly. So not only do we have this constraint, we also have a non-negativity constraint, but we don't have to worry about the non-negativity constraint unless something weird happens. Okay, so I'm going to skip the non-negativity constraints for now. I'm going to click on solve. Okay, so non-negativity constraints are useful if demand values turn out to become negative. So all you're saying is that demand has to be positive, demand can't be negative. That's essentially what you're saying. So if I go back to the PowerPoint file, let's see if we get the same answer. Nope, we got a completely different answer. Nope, we got the same answer, 162, 127 and 95. This is exactly the answer that we got, and that's pretty much the problem. So again, it's the exact same model. The only difference is in the previous case we were looking at the prices as different prices for different segments in the market, but now we are looking at price as different prices for different times when you sell the item. So it's dynamically priced that way. But otherwise, the mathematical model behind it is exactly the same. So that's that. So that was the first model. So I'll stop this video here, and instead of going for another 10 minutes, I'll just record another video. All right. I'll see you all in the next video. Take care.